about time series. Of all the statistical tools, I find time series more powerful, more empowering, more rewarding than all analysis I've ever done. Because today depends on tomorrow, on yesterday, and the days that are preceding today. The events that have brought us here did not start today. They started long time ago until you reach here. As they famously say, you cannot connect the dots forward, you can connect the dots backwards. When we want to analyze historical data, that is time series. If you trace why we are in Kenya today, looking at various migration routes that we found ourselves here, there are people who started all the way from Congo, passed through Uganda, Zambia, Tanzania, and then came to Kenya. Over years, it did not just happen in one day. Then there are some of us who started our journey in Egypt. Our great grandfather started in Egypt or Mesopotamia. They came all the way up to Sudan as a stopover. Then from Sudan, they came all the way to, some went to Ethiopia with the other White Nile that has followed the Blue Nile, down to Uganda. We settled around the lake, some went to Tanzania. The historical data is what makes us who we are. History. For those people who are in economics and business and doing forecasting, you have all the data of a bank from the time of its inception to the time it's mature enough to trade in the stock exchange up to now. That data is very useful. And that is time series. So once you understand the significance of time series, you are empowered. Anything that is existing today as a history, that is time series. From the word time and series, these are events, observations collected over time to the point where we are analyzing them. That is time series. That is, once we understand time series as succinctly as possible, we are able to relate with it. If you look at your progression from the time you are in baby class to the time you're in nursery to the time you are in high school, primary, high school, first degree, second degree, and now PhD. There are certain milestones along the way. But you see the evolution of your academic journey over the years. It can be broken down into days, your first day in school. That is time. We measure time with seconds, microseconds, seconds, minutes, hours, days, weeks, months, years. So we can measure that from your first day in school and look at it. You can measure that in your first week in school and weeks that follow, your first term in school and the terms that follow, the first year in school and the years that follow. That is time series. If you give birth to a child and you just want to focus on one very linear and lean aspect of their lives, which perhaps is just weight. First time this child had 3.5 kg when born. After 1 week, the child is maybe 4 kgs. Another week, maybe 4.5. Like that. Up to the time this child is, let's say 15 years, but you've been recording daily, weekly weight of the child over time. A professor we worked with in South Africa invented something called infantometer. This infantometer measures the development of an infant from the time they are born through the time they are 13, and it changes. Its purpose is to detect deviation from standard weight, and maybe at certain times inform the doctor or the mother to do something about nutrition. That is time series. That professor is from Northwest University of South Africa. Now, anything you do over time, anything, even if it is family, you'll realize time series has a lot. Even if it is marriage, you and your spouse met when they're just the two of you. You didn't have a car, you didn't have a house, you didn't have anything. The only thing you had at that time is love, and maybe a rental. Then within some time, there's one child, second child, three child, four, and you've acquired certain things along the way. That's time series data, which we can analyze. So when we talk about time series, we are not talking about very strange, peculiar things that we cannot grasp. No. It is these things that we refer to as is time series. For instance, if you look at GDP since independence, all the way to today, 62 years after independence, you will have 64 observations. If you plot that, you'll find that there are certain areas, the certain years when the GDP plummeted, areas that it rose. That is time series. While still talking about financial data, if you again track Kenya's budget from the time of independence up to today, 62 years later, those will be 62 observations, you will find the evolution of this budget until now. You will realize that when we have got to 1.3 trillion in our budget, you will find certain changes. For instance, when did the trillion budget start? Up to now. Time series will tell you when that's that trillion, but then you look at some structural changes that happened at that time. Perhaps if you go further, you'd begin to see where we started having budgeted corruption, where budgeted corruption is only means if Peter Wasike is my friend, I am in government, and the Minister for Health, maybe I'm the president. We put something into policy that every primary school will have, every child will have a laptop. And then I tell Wasike, get as many laptops as possible and overprice them. So where a laptop was supposed to be, a tablet supposed to be 10,000 Kenya shillings, now they'll be 50. And if it is for the entire country, we will be talking about billions. And now you begin to see, using time series, when our national budget began to blow up unnecessarily. I like the fact that during the time that I was in university, there were some people, I was doing my other earlier degrees, there were some people like Mwalimu Mati, a wonderful person who used to crunch those figures, the budget, and tell us when, this was in civil society, what budgets were not making sense. That's when you will appreciate that everybody, we need everybody in governance. We need accountants, we need everybody in governance. So that is time series. So time series will help you understand certain changes, even in our education system. For example, from independence up to certain times, the enrollment all of a sudden increased. For example, when President Kibaki came to power and all the aid that had been stopped because of the autocratic Kano regime were released, and now we could afford free primary education, a lot of people enrolled and some transitioned. So if you look at time series data, you reach 2002, then you see a lot of enrollment in primary school like that. Historical data can tell you a lot about things that happened in this country. So that is what we understand historical data to mean. That is what we understand time series to mean. And that is exactly what time series is.
Prof.
So when yes, go ahead, please.
Oh, sorry to cut you off. I would just like to quickly ask a question with regards to this time series. When you talk about longitudinal studies where you study a certain phenomenon over time, are they different, or is time series purely based on reviewing secondary data? What's the difference between the two?
Let's say I like going to health and medicine. Let's say, for instance, that we are giving some intervention today for a vast number of people, and we want to analyze the effect of this intervention in 10 years to come. That, if we analyze it in 10 years to come, that is time series. If we analyze it now, like we do an intervention. We don't do, we just want to study a certain phenomenon now. That is panel data, just panel data. It's not time series data. But if we have to track it, and when we measure it, the measurement says that we do this maybe weekly up to the next 10 years, that is time series data. Panel data is mostly used in transverse analysis when we want to note the extent to which certain phenomena is occurring, is happening. We use panel data. The danger most people have in using time series data is, one, it is the time factor. You have to wait for that long time. The other is the cost of research, like prospective research, where you are going to follow something all the way to the time that you think the impact begins to appear, seem to be long. So for that matter, most people like using secondary data. And by the way, in most time series data are always prospective. Most, not all, prospective. Prospective. If you look at the time when we started having CDF, that was in 2002, and today is it's around 23 years. We can compare those 23 years from 2022 today, and those 23 years from 2002 going back all the way to 1978, and see what development have taken place, the effective use of that. That is equally time series data which we can compare. So I was giving you background of time series data so that you internalize, we begin to appreciate, understand what time series data actually mean. When we talk about time series, it is evolution of a phenomena over time. So when we successively collect data on that phenomena over a period of time, the data that we collect is called time series data. If we chronologically collect them sequentially until a certain period of time, that is time data. It is analysis of time evolution. Most of us, if you look at your photo when you're in high school Form 1 and your photo today, you will see what evolution of time does, what time does to us. This is a very powerful tool if you look at it in that respect. There's been a lot of growth and development, also associated with aging. So it is an evolution. It also enables us to construct a model that will describe history, and it also enables forecasting. For example, what you see the weathermen do, they try to forecast what the weather climatic conditions will be in, let's say, next week, maybe in years to come. What has enabled forecasting easier in this generation is computer simulation or statistical tools that are used to simulate data. which you may necessarily use seed data to do forecasting. But the most accurate forecasts are based on time series data, is data collected over time. Then you make certain prediction. This is the kind of statistics analysis where, quantitative analysis where we say time equals to t. It's a serious variable. We have variables t, which is time, and yt. Let's say our y here is age. When you say yt, where t is 10 years, we're talking about age at 10 years, yt. If we decide it is xt, maybe x would be maybe weight at 5 years, xt. So that t will only symbolize the time, it demarcates the time we are talking or referring to. This is a situation where we are only tracking one variable over time. We are only tracking one variable over time. But there are situations where we have tracked several variables over time. I have published around 3 publications on time series where we tracked youth unemployment over a period of time. We used youth unemployment as a dependent variable, used external debt, ED, from independence. We used population over time. We used GDP. We used education over time and analyzed how these impact or influence youth unemployment over time. I would share those publications after this class. Then you can see how we can use several variables over time. But for a RIMA model, it is univariate. When we say univariate, we only mean one variable. So we can see changes or in one variable, evolution in one variable over time. So here we only have 2 variables. One is time, the other one is whatever we are measuring over time. Now, there are cyclic components of time series. What are the components of time series? One is trend. If you didn't know, trend is a serious component of time series. Trend. Trend means evolution over time in the long run. When we talk about time series, there are terms that we are going to use here that maybe how you know them is different with how they are known statistically. For example, trend is evolution over time. Something how it goes over time. Then we have short-term and the long-term effect. When we say in the short run, we means in short term. When we say in the long run, it means long term, over time. The words we are going to use like stationary or constant. You might be wondering, how can something be stationary? And yet we're talking about evolution over time. when we say something is stationary, we only mean that if it increases, its increase is not influenced in no way, in any way, by the past and the previous. So it's stationary. It's just independently increases. So it is the opposite of correlation. So stationarity is the opposite of correlation. And we mostly use stationary data in time series analysis of, like, for example, so when we get correlated data, which means an observation today is influenced by observation the other time 2 years ago. So we have to make it stationary. Now, when you talk about trend, there was a time when I was growing up when there were some genes, they were called SAVCO. And people say, SAVCO are now trending, and they're the in thing. That's how most people know trend. Our parents used to have bell-bottom trousers. That was the trend at that time. That is how most people know trend. But trend is evolution over time, as it is used in time series. Then we have cyclicity, the cyclical component. Have you realized that certain things are quite secular in nature? Take, for example, 1 year. Look at the movement of the sun when you track over 1 year. Sometimes it's the Capricorn, tropical Cancer along the equator, and that repeats itself. Cyclic. Once we know people, and this influence events that people do. For example, people start cultivating land in January, it's dry. So every January, people are cultivating land. At least some of us who came to Nairobi by bus, not by birth, we know that people start cultivating land in January. And by March, the planting, because there are rains coming in April. So this happens every other year. So it's cyclical, cyclicity of it. So cyclicity or cyclical component is a nature. Cyclicity is a component of time series. The other one is seasonality, derived from the climate aspect of seasons, seasonality, seasonal. In 1 year, we have certain seasons in Africa. Let us not talk about the Western aspect of seasons, spring, summer, what and what. Let us talk about here where we live. We have seasons of less rain or drought. We have seasons of rain. Which actually in Africa, if we try to Africanize our thinking, is that our seasons have a lot to do with agriculture, planting season, weeding season, harvesting season, and celebration season. You will realize that those seasons are constant over time. But lately, they are being affected by climate change. where weather becomes unpredictable and we get extreme weather, an adverse effect from that. But essentially, they remain seasonal. It is that seasonality that is also related to, there are some studies that have been done. For instance, the people who are, at least those who are in a NASCOP, National AIDS Control Program, realize that there are new infections after Christmas. Social events are also seasonal. People have been working hard the entire year. This is Christmas, they let go. And things happen. Seasonal infections. And then they also realize that this seasonal infection mostly affecting teenagers more than other groups that are sexually active. Then you also, during Easter, another season, and they see Easter is associated with other social activities, events, like safari rally. There are also certain infections that are finding coupling effect during Easter. We are still talking about seasonality of time series, components of time series. Now, after talking about seasonality, we are talking about irregularity. You will realize that most natural occurrences do not happen in a straight line. Those straight lines only exist in sometimes in our ideal academic work, but most of the time they are always irregular. If you look at financial data over time, there are times when you're seeing spikes jutting up and down, up and down. That's what we call irregularity. Let me see if I have any that can describe irregularity so that we talk about what we know. Just to give an example of what the irregularity is. As I look at it, somebody might be having a question running through their mind. The other time, Millie says that she understands mathematics until we start calculations. I'm looking for irregularity so that I can show what it is. when I was teaching epidemiology, yes, I've got it.
Prof, I have a question. For these components, can they be able to be shown in a graphical format?
Yes, that is what I want to do.
All right.
Yes. There was a time I was teaching epidemiology, and I had such graphs. Yeah, this is as it suggests. This is data graph from CTREP. CTREP is situation report. This was during COVID, where you look at this. Since 2013, since March 13, 2020, when the first case was confirmed in Kenya, a total of 251,152 confirmed cases, 5,181 deaths, giving a case fatality rate of 2.1, have been line-listed. Of these, 243,153 cases, 97%, were local transmissions, and 7,997, 3%, are imported cases. They're presented in the figure below. So if you look at this, it is not a straight line. There is seasonality. There was seasonality of COVID-19 infection. Now, if you look at the peaks, there are 4 peaks: 1, 2, 3, 4. They also coincided with seasonality of COVID-19 infections. If you look at all of them, let's start with the first peak here. You see that if you look at the graphs, there is the bars, there's irregularity. One bar is high, almost getting to 3,000 cases or 4,000 cases in one day. Another one is lower here, 150 cases down here. This is what we call irregularity. Even here we have, we have cases here. Let's look at this peak where my cursor is. The next one is here, 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 here. That is what we call irregularity. So when we talk about irregularity, that observations are not equal, they're fluctuating. That's what we mean by irregularity. Fluctuations and soaring of observations are called irregularity. Then seasons, you can see infection, like this was December 2021, this one, the 4th peak. If you see the seasonality of the infections, up to this time, there were just 4 peaks. But in the book that you have, there were 7 peaks. So even if you look at financial data collected over time, they appear like this. Should it be GDP? Should it be external debt? Should it be foreign direct investment? They appear like this. So there is seasonality here. There's irregularity here. If we had gone for more than 1 year, there would have been cyclicity, which is as well described in the book. So, and then the trend here over time, you will see how peaks come and decline. That is a trend. So when we talk, and these are taken, the data taken daily. So this is a typical, a quintessential time series presentation of data. This is what it looks like when we are talking about time series data. So most of us who are in economics, most of us who are in business studies, this is what they look like. I'd also like to point out that I am a time series specialist. I have studied time series during my PhD. I have worked with the time series elaborately and created my own models on analysis. And that's why I was in a position to lead a task force that was analyzing and predicting COVID-19. So I appreciate the power of time series. And I want you also to take advantage of this experience and find a way in which, if somebody wants to do something on financial data but wants to use time series, I would gladly be there to support. Yes, Vidya, question.
Thank you, Prof. My question is just on what you're talking about, because yes, I work in an organization where I'm required to do forecasting, especially for our business. But you find that sometimes when you do that forecast, the owners or the GM is already biased, and they kind of want to push their own agenda. How do you normally deal with this, especially you working for some of the government projects where you know this is the right direction to take, but because of external factors, then you're not able to deliver that?
I have a question for you. Have you read the book that I suggested?
Not yet, Prof. Maybe I should.
I have been in the same situation where you are. When I first made my predictions of COVID-19 infections, KEMRI, which the only organization in Kenya concerned with that, disputed. CDC, including Africa CDC, disputed. My alma mater, University of Nairobi, we had people in that group. They disputed. Jomo Kenyatta disputed. I was only alone. I was only supported by one professor, Professor Kama, who said, I think Shem is right. So we said, let's wait and see. And by that time, the British Council by that time it was called FDI, now it's called FCDO, brought two professors from Oxford, Julius and Mackenzie. They came with their model and made their predictions. The short part of that story is that all else failed except my predictions. Thereafter, there was no dispute about whichever thing we predicted with the model we developed. I would suggest one thing we seriously face in science and forecasting, there is what the organization wants to hear, and then there is what the truth is all about. There are two consequences that come here. One, if you agree with what they're trying to say, and then it becomes wrong that what they were saying was not actually what's happening, then your credibility goes down. And there is nothing as unsettling as making wrong predictions. I remember Cambridge called a press conference after their predictions failed to apologize. It's also recorded in that book, where the director said, sometimes you get what you had predicted, sometimes you don't. It was a very good apology in that. And nothing erodes credibility as prediction and forecasting. If you forecast something that does not come, your credibility is thoroughly eroded. And that's why I sympathize with the weatherman. So these days, you see the weatherman gives generalization. They are not very giving the specificity because their credibility is on the line. Somebody said in one of those predictions, I think I've also recorded it in the book, that if you don't want to experience the churning of the stomach, the anxiety that comes with predictions, become an accountant because they deal with what they see. Leave science alone because you can have ulcers. Can you imagine being a coach of our famous Manchester United, and you think you're going to win this case, you have all your roots, and it doesn't happen? It's a bad feeling. So my advice for you is to have two versions for the sake of your job. The version of what they have and the version of what you know the truth is. And tell them that the best case scenario is this one. The worst case scenario is this one. So that when it finally happens, you are covered. I hope that is helpful. So
No, thanks, Prof.
I would want to go into something now that we've shared the forecasted, not the forecasting, now that we've shared the irregularity, seasonality, something like that. So we have not even begun talking about a Riemann model. We were still discussing time series, what it means and its components. So what are the assumptions of a Riemann model? measurement of data must occur at random. That's why we have stationarity. And data is uncorrelated. This observation is not correlated with the other observation. The deterministic component is only one constant.
Morning, Prof. What is ARIMA model? Are we still continuing?
Yeah, we're still continuing. I'm going to tell you what it is.
Well,
Yes. So when we talk about ARIMA model, ARIMA means AR part is called autoregression, auto, where T, the next one is T minus 1, T minus 2. There's one, T is today, our time T is today. Yesterday is T minus 1 day. Then on Thursday is T minus 2. On Wednesday is T minus 3. So it is a time. So autoregression is the AR part. Then I in ARIMA is integration, the integrated part. Then the MA part is the moving average. So the autoregression and the moving average are integrated into one. That is the purpose of that integration you see in there. So ARIMA model is self-regression integrated with moving averages. And it's a statistical model. Now, all these are abbreviated as PDQ, where P is the number of lags. Why do you know what lags are? You actually know, except that you have not convinced yourself you know what a lag is. Sometimes you say, hey, these people are lagging behind. That's a lag. So when we say a lag of 1, when we measure our data with 1 year, lag of 1 is 1 year ago. Lag of 2 is 2 years ago. What were the observations 2 years ago? Lag of 3 are 3 years ago. Now P is measuring the number of lags. I know those people in financial data are enjoying this, that lag. So some of these things that we use in daily language are actually statistical language. Lag, lagging behind, a lag of 3 months, a lag of 1 month, a lag of. Then D is the autoregression, and Q signifies the moving averages. And we're going to analyze this using R. If you don't want to calculate it. Yes, go ahead.
What I'm asking is, we've been talking about time series.
Yes.
What is ARIMA model in relation to time series? Is it a component of time series, or is it a different?
It's a component of time series, yes.
Okay.
There are 3 models of time series. One, which is more complicated than all of them, is autoregulated distributed lag model, ARDL. It combines several variables and trying to make analysis of all those variables in one run. Then we have Markov processes. Markov was a Russian, came up with that model. The Markov processes. Then we have the ARIMA model, which is the most popularly used among the people who are in time series. So those are three models that the most popular three models that we use in time series: Markov processes, autoregressive distributed lag, and ARIMA model. ARIMA, good thing about it is it's easier to understand. So I wanted to show you, after we've talked about the components, we talk about the hypothesis here. I want you to understand that the statistical hypothesis differs from, or the quantitative hypothesis is different from the qualitative hypothesis. Here, we're saying that our null hypothesis is that, our hypothesis, the first hypothesis here, we're not going to use this anyway, but it's good for you to know that we say that the result of the variable we are talking about is influenced by addition of all the components, the trend, the cyclicity, the regularity, all of the cyclic nature and the irregularity, the trend, and the seasonality. The additive nature informs the variable we're dealing with. Or the variables are, the variable we're dealing with is informed by multiplicative nature of time, of trend, cyclicity, irregularity, and that. So that is that. Stay patient. Now, when we talk about a univariate, that ARIMA is a univariate model. In that structure, that equation, you are only seeing one variable, yt. So I want you to pay attention and look at my cursor. The dependent variable is also the independent variable when we talk about univariate. The difference is the lag. So this is the constant which we agreed when we were talking about the assumption here that there is only one constant random. The deterministic component is only one constant. This beta naught is that one constant. Now, beta 1, beta 2, up to beta p. P is the number of lags, are coefficients of regression when we finally regress this. But yt minus 1, yt subscript t minus 1 is the previous data. If this was a daily data, then yt minus 1 was the observation yesterday. Then yt minus time, 1 minus 2, is the observation 2 days ago. Then yt minus p is observation p days ago. That p can be 10, 20, whichever days, whichever one. Then et. I like this guy.
Mwalimu, what does the T in the time series mean?
Time. It only means time when the observation was made. It only means time when the observation, like when we say t minus 1, minus 1 means a lag of 1, a immediate previous observation. Let's say, if a child is 15 years today, that is T, not YT, that's just YT, T today. If a child, last year it was 14, that is T minus 1, minus observation of 1 year, so YT minus 1. So here is YT, observation the previous year, let's say. 2 years ago, this child was 13 years ago. That is T minus 2, observed 2 years, on the value at 2 years, age at T years. So here, our dependent variable is 1, univariate, and it is T, YT, Y. Let's say it is age. Then these are the lags 1 year ago, 2 years ago, 3 years ago. This is to see how previous observations affect or influence today's observation. This is something that we mostly don't see in our analysis. ET, the error term. There's that symbol, that mathematical symbol, Greek symbol, is called epsilon. Epsilon is a stochastic error. By stochastic error, we mean unexplained error. Let's say we are talking about, let's say, GDP. Then GDP has always been a constant, increasing at a constant. Then in 2014 and part of 2015, the constant is a little low. Then we wonder, the financial analysts think, oh, the companies, there was increased taxation, there was this and that, but there's still some variance that is not explained. Now, if you are somebody familiar with the situations around my country, you realize that 2024 and 2025, there have been massive demonstrations, during which time the economy could have declined. But because you did not consider the impact of that demonstration in your model, that variance which is explained is fed into the error term. So that is the significance of this. Now, when things are said theoretically like this, they look very strange. They look very, very strange. Just like lab results, somebody said that in their lab, everything works, everything does not, they know the theory, but nothing works. Then that is in theory. You know everything, but nothing works. But the practice, everything works, but you don't understand why. Now, we are going to run this in our R. I don't know what time it is. I want us to take 5 minutes break only. Then we are going to analyze this using R. During that time of 5 minutes, I expect that we organize our gadgets, open your R console, then we are going to run. we're even going to do forecasting today. Yes, Dr. Livingston.
Yeah, I think this reminded me when I was a financial researcher. I did a similar project in my master's. Probably it can bring context to what you are explaining now. If you allow me
Wonderful.
1 minute.
Go ahead.
Yeah, so I was running a research on the impact of insurance distribution channels on growth of insurance in Kenya. And when you do insurance distribution, you have three major channels. You have the bank assurance, you have agents, brokers, and the direct distribution. So during my research, I got data over a period of 10 years to show what has been the impact of those distribution channels over a period of time. So beta 1, beta 2, and that period now, every year, so the data I got from different insurance companies shows how much of the insurance business comes through bank assurance, through agents, through brokers, direct. Then I analyzed it over a period of time. I didn't publish that paper, but I can relate to what you are saying and the results therein.
Yeah, thank you very much, Dr. Livingstone. What we are doing here is not strange. As you can see, what Dr. Livingstone has done before, I would encourage you that everything we're doing here is relevant to policy, is relevant to research, is relevant to our daily lives. So take those 5 minutes, stretch if you must, but we are coming back to analyze our data using ARIMA. And we shared one yesterday. Wasike was kind enough to share it with everybody. We are going to do that, okay? Let's take those 5 minutes. we can continue.
Prof, we've seen there's a journey to heaven. I don't know if you are aware about it. Did you do a regression analysis for the journey?
No. I haven't. Our brother War has disclaimed that was not him who made that prediction. That has nothing to do with the time series. Even if we analyze from the time of the Noah floods, whichever floods, those will be 4,000 data points. That would not be the case. I'm not. Somebody made a joke yesterday that if we meet on Sunday, we are in heaven because the world is coming to an end on that particular day. So I don't know if I am in heaven, but I know I am still here. How many of us have opened our R console? Okay. You are not in hell. We are here. Okay. Now, if you have opened your R console, let me share what you have to do. You have to install library ggplot2, and you have to install library forecast. That's the first thing we are going to do here. I cannot share my screen. The host has disabled screen sharing. Peter.
Yes, Dr.
I wanted to share.
I'm not the host, it's Dr. Mwaka.
So.
The rights have been given to Alex, so probably Alex, you need to make Prof the host or co-host. I don't know.
Or you allow multiple participants to share screen.
Yes, Alex, please go ahead.
Maybe you can hear whether Alex is here. We don't know.
The phone. Let me try and
Tracy, you are installing ggplot2. Okay, let me share the screen. Okay. There we go. We are installing ggplot2 and forecast. So how many of us have ggplot2? At least those who have who did ANOVA have ggplot2. Let me share I can have two R's running at the same time. I have several versions of R. Let's use the letter. Don't go to RStudio, just go to
Excuse me, Prof, how do we download the ggplot?
Okay, we are going to download them. I'm going to show you. We had covered this in the other class. And we are going to do this together. So if you're seeing my screen, somebody should raise their hand in case they're seeing my screen. Okay, Tracy. Now, thank you, Sain, and the rest. That's wonderful, wonderful. Now you go to packages. You see the packages? You select packages where my cursor is. There is file, edit, view, miscellaneous packages, Windows, and help. Now we go to packages. The first thing we do here is to select CRAN mirror, where we agreed CRAN means comprehensive R archives networks. So let us go to South Africa network. Once you set CRAN mirror, South Africa is the nearest to us here. There are all these countries. Kenya is not one of them. Neither is Uganda nor Tanzania. Only South Africa. thanks to our laziness, we are not there yet. So South Africa, Johannesburg. If you go there, you scroll, you find South Africa, Johannesburg, and click OK. If an error does not come, means they have allowed you. How many people have been allowed to use the South Africa network?
Mwalimu, I'm not seeing that on the MacBook.
Mm-hmm. Yeah, MacBook has issues with this. So what are you seeing in MacBook?
When I go to the packages and data, there's just package manager, package installer, data manager.
Go to package installer.
Okay. Oh,
Look for South Africa.
So there's no list like the one you are showing. Okay, sorry.
Okay.
Thank you.
Wonderful. Now,
Mwalimu, I'm not seeing that list. I can only see arrows.
Arrows?
No, okay, not arrows.
You go to package, then set CRAN mirror. You select CRAN mirror, then all the countries show up.
I'm not getting any of those options.
Joy, are you using the a Mac or a Windows?
Windows.
Okay. Because on the Mac, it doesn't give the options, but if you click get list, then you scroll to the bottom, you find South Africa.
Mm-hmm.
Also, Mwalimu, so once you click South Africa, what are you supposed to do? Because now it's showing A3, Allen.
No, if you just click South Africa, if it doesn't give you error, that's okay, just leave. Then that is when we go to back to packages, okay? After you set mirror, now you go back to packages and select install packages. Then they begin to appear from A to Z.
Excuse me, Prof. Mine is telling me to choose CRAN mirror. Trying to use CRAN without setting a mirror. Was I to set a mirror somewhere?
Have you selected? Are you using Mac?
No, I'm using Windows.
No, it doesn't require you to set a mirror anywhere. Or you did not, you went to packages directly without selecting the mirror?
I think so.
No, you have to select mirror first, which we said you go select CRAN mirror, you go to Johannesburg, then you select. After that, you go and select packages again and go to install packages. Then we scroll down. They are arranged alphabetically.
I set CRAN mirror.
Okay.
Then I came to South Africa.
Good. Then what did it tell you?
So now what I have is choose CRAN mirror. Is that it?
Yeah, you have to click it and say, okay.
Sir, why does Apple have monopoly of softwares?
Americans are crazy about the intellectual property.
No, but you see, it inconvenience a lot of people across the globe and even us.
Yes.
Simply because we want to adopt Apple, yet Apple is not fully fully compatible as compared to, let's say, like Android or Windows?
Now that is their intellectual property.
So now, how do
Have
they
you
run
ever
R from their end?
tried?
And it's built on
Right?
it's Python, yeah?
Yeah. So most of us prefer Windows instead of Mac because of too many inconveniences. I have published a paper with American Journal sometime in 2022. The kind of things that they made me sign, I felt so bad. It was a journal of statistical simulation.
Were those NDAs you signed?
Yes. So.
But those NDAs which doesn't make sense, eh?
So after you select ggplot2, you click OK. Then it begins to run.
I'm still looking for it.
Oh yeah, please look for it. They are arranged
Sorry, what's the word you're
alphabetically.
looking for, Prof?
So, Prof, take us step by step. Some of us are lost. We didn't attend last class, and it will not be. If we get
So
lost twice.
Are you on Windows?
Yes, I am. I have picked the crown mirror. Choose. Yeah, I can see that.
Yes.
So what is the
go
next?
back to packages and install packages. Where the list where you chose crown mirror.
Yes.
If you go down, this will install packages.
Yes, yes. I have.
Select it, then it will open another screen where you see all the packages arranged from A to Z. Then look for ggplot2. Now, that ggplot2 enables us to do, after we've done analysis, now we do visualization. It enables us to do visualization.
Prof, mine is telling me, would you like to use a personal library instead?
I just say yes.
Okay. Would you like to create a personal library?
Go back. Just go back and say no. To avoid all that.
But it has started running.
Oh, it has started running. Is it downloading?
So it's telling me that it's saying. It has, oops. The downloaded binary packages are in users, blah, 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 blah.
Okay, it has. How do you know that you have installed it? Type in your R console library to see if it is there. Library ggplot2. Like I've typed, it is there. It doesn't give error. It just tells you where it was and so.
It gives the same message as yours.
Okay, wonderful. Then now go back to packages.
Prof, mine is still telling me there's no package called.
ggplot2.
Yeah.
It's not successfully installed in yours if it says so.
So how do I install it?
You go back and reinstall it. You go back and reinstall it. Yes, Joy.
Not yet,
Okay,
but I'm on it.
wonderful. Now we go and install Focus, library Focus, because we are going to focus this data. Now you don't have to set CRAN mirror because I already set it. So you just go directly to install packages and go to Focus.
Prof, do you mind if you go back after where we have the downloaded binary package are in after that phase?
No, immediately after, if you install the package, if you are going to install a package, after you would set the CRAN mirror, you don't need to set the CRAN mirror again. You now go directly and install. Unless if you close that R and you're going back, then you'll have to reinstall. But if you're not close to your console, just go ahead.
And install the package, right?
Yes, install the package.
So which Focus?
Focused.
Which one?
It is just focused. Focused there. They're many, but the focused alone.
Mwalimu, here there's only focused MDS.
Only.
That's the only focus there.
Let me check if that is true. I'm seeing focused LSW. I'm seeing focused ML. I'm seeing focused SNSTS. I'm seeing focused TB.
Sorry, Mwalimu, I was in focus.
There's focused up there. If you scroll up,
There is focus. Before focus combinations, there's just focused up there, yes. So select it and click OK. You see, it is installing so many things inside it, which is good.
Prof, you may go back again if you don't mind. At the packages, where do you pick now the focus?
If you click packages and then you choose, you had already, had you selected CRAN mirror?
Yes.
Okay, then go to install packages. Select it, it will open a big drop down somewhere. Then you're going to choose ggplot2, and after it has run, you go and pick focused.
Mwalimu, were we doing something else?
Yeah, I had shared some data in class. I want you to call it and we want to use it. We want to run a RIMA model.
Yeah. Where did that data in class, where is it?
Ask Wasike.
He shared it on the WhatsApp group.
So how
So,
do you
Prof,
call
this
that data?
RIMA focused MDS.
No, just focused only. If you select that data,
Prof, I'm only getting focused MDS.
Only there's a focused before, just before focused combinations. There's focused.
Is everyone using the same version of R? That's also another question.
Prof, that focused is under what?
Packages. You haven't.
FORECAST. Guys are looking at FOCUS. Guys, look, go to FORECAST. Forecast. That's where it is.
It is not FOCU. No, it is like forecasting. Yeah. Thank you, Caroline.
So,
Excuse me.
Yes, go ahead.
I saved my Excel sheet as COVID data. Maybe I saved it wrong because
No.
it's telling me unexpected symbol in COVID data.
You have you used this? And then put it on the chat box. No matter how you save it, if you just call it like this, it will come. Let me just put it in chat box. Then when you call it, it will just come. Hussein, have you called it?
Prof, I have a question.
Yes, go ahead.
When I'm calling the data, it opens a box where I'm supposed to pick the file.
Yes, pick it from whichever you saved it.
So when I pick the file, I expected to have an output like yours, but it's just loading.
Why is it? It is still loading.
Yeah.
I think you have to write again COVID to call it.
No, I just write, yeah, that's what you mean by calling it. Yes, thank you. That's what you mean by calling it. You just have to write again.
It has worked.
Wonderful. How many people have been in a position to call it? By show of hands. Thank you, Simon. Thank you, Carol. Thank you. Thank you. Thank you, Zara. John. Thank you, Georgette. You are wonderful people. Tracy, thank you. You are wonderful people. Benjamin, thank you. Thank you. Now that we have this data, We only want to use cases data here. From the first day Kenya reported COVID-19, reported COVID infection. I've chosen it because it's the one that does not have zeros. I think we learned how to, it is variable number 2. So we can put it COVID-1 or COVID-2. Assignment operator, COVID, square bracket, 2, close square bracket, and then call it 2.
Mwalimu, what have you done there?
Hit the formula.
Yeah, let me put this here.
Mwalimu,
Yes.
I am several kilometers behind.
You are lagging.
Yes, I'm lagging.
Okay.
So I am in that time thing.
Yeah.
You are in which?
College.
No.
Yes.
I've now that I've managed to save, how do you call it?
You just type. You managed to save that data.
Yeah.
I have put in the chat box how you import that data into your R console. COVID assignment operator read.csv file.choose, open and close an empty bracket, then close all the brackets.
But that is if you saved it as COVID too.
Even if you've saved it as COVID, it will just come. Because we are giving it, by assigning means we are assigning it a new name here in the R console.
Excuse me, Mwalimu.
Yes.
I typed that in the chat. What is wrong with my command?
What is it telling you?
It's telling me error, unexpected symbol in COVID data.
Aha, you want to share your screen?
Okay, will I make it? Let me
Check sure. No, this thing is case sensitive. It is case sensitive.
Oh yeah, I saved my data, my COVID data with a capital C and a capital D. Could it be affecting?
Is how you have assigned it on the R console, this is the same way you call it. Not how you saved it, just the same way you've assigned it a name in the R console.
I share my screen? Or is that...
You want to share your screen? Let me just checking something here.
You can finish and then I can see you later.
Okay. Just let me stop sharing. You share.
I have disabled participants.
Oh.
And share
Mine is
screenshot,
COVID,
Victoria.
COVID not found.
Okay, let me share a screenshot.
Yeah, in the chat box.
Yeah.
It's still coming. Now, one of the things that coding or data analysis teaches us is patience. Patience.
Hello? Dr. Shem, maybe you could also elaborate on the type of bracket, because I noticed that's the difference.
It is a square bracket.
Yes, now that square one would bring, I would successfully call the data, opposed to the other version. That's what I noticed is the difference bringing the error.
But I think Victoria is still in the first step where we were calling the data. So Victoria, if you could just call your data COVID instead of calling it COVID data, just write COVID assignment operator and then read.csv into file.choose and then bracket, and then you close the bracket. Let's try that if that works for you.
Okay.
Is it dependent on how I saved it?
How you assign it.
Yeah, let me, I think I'm just choosing it now in the, let me look for it. Thank you. I have called it. What's the next step, please? Thank you.
I know many people have not called it.
Okay. That's good.
I just want to separate it from where it is and share. So it will save us more time because I see I shared a big data set that is having problems. So who was, can somebody share with me the email address to then they share with the entire group? I've separated it so that we can go faster. Let me see. Let me check whose email is here. Mm-hmm. Yeah, Wasike. Is Wasike there?
Yes, I'm here, Dr.
I am sharing this data with you.
Okay, let me check.
And share with the class. Yeah, we shared.
That's that. I'm only seeing the one you sent on Friday.
The one I've sent now.
Does not yet hit my inbox.
Refresh your inbox.
Is that different from the COVID data?
Yeah, it is. It is not different, except I do not want people to struggle in separating it from the rest. But it's good to know. You see, when it goes nice standalone.
Okay.
Dr. I'm refreshing, but it is just this.
Your Gmail.
Oh, Gmail. Sorry, I was checking my school email.
Your Gmail.
Let me check. Inbox.
Mwalimu, a question as we load the data. Is there a way of deleting previous commands? Sometimes you find your console is jumbled up. Is there a way of dropping some of the commands, or you just have to live with them? Thank you.
Just live with them.
Okay.
I suggest you use the one that I have shared. I am seeing the loopholes in you trying to use that other one. I'm putting it on chat box.
I'm having a challenge accessing it. I can't see it anywhere. Yes.
Okay.
Perhaps you can try somebody else's email and see.
Mwalimu, you can try sending to mine. I think I have access to my email.
Where is your email?
I shared it on the chat box.
Oh, you shared it on the chat box. Okay, let me try.
Sorry, I've seen it. It went to my spam email. Now I can see where it is.
Okay.
I'm wondering why is it hidden? So let me download. Good. I think it has come. Is it the one COVID in caps .csv?
Yeah, it is. I've just sent it as COVID.
I've posted something. I hope it's the one on the wall. Press 851. Let's see if I can also download it again. Can anyone confirm if they can access it?
I can access it, Peter. Thank you.
Where is it?
On the class WhatsApp group.
Okay.
Yeah, Helen, and David, and Livingston I've sent.
This looks like an image. Oh, okay, sorry.
So once you have it, you can call it.
Prof, if we had done the first initial steps that you had directed us, should we go back and upload these other data, or should we just continue?
This other one. I'm seeing loopholes. It will take too long selecting. So I'm seeing loopholes. Just download this. I've shared the codes. There we go. So once you are there, we are good to go. Then we can start. That is data collected for 967 days. How many years are those? Almost 3 years then.
Yes.
So that is called COVID data for 3 years.
Can I just ask something, Dr. Prof?
It's okay.
I used lowercase and it still came. So it's still okay? Or do I go back to?
Does it look like this
Yours
one?
was uppercase. Yes,
Does it
exactly.
look like mine?
Yes.
Wonderful. Just maintain that lowercase.
Okay.
Well, how you assign it on the R console, how you assign it a name on the R console is how you call it when you come to calling it.
Did you scroll back up on how you've assigned it?
Yes, yes, yes. Let me close this down. How many people are there? Okay. Wonderful, wonderful. This is good. So can you, after that, can you type library ggplot2 then library forecast. Like that. Okay.
Mwalimu, mine is saying package or namespace load failed.
Why? Why did it fail?
It says there's no package called GTable.
Did you download it successfully?
The ones we were downloading in the start of the class.
Yes, yes.
Yeah.
Those are the packages that will help us run this AREMA.
The forecast. Yes, I did.
Okay. Forecast.
Yes, like yes.
And ggplot?
Yes.
I'm challenged here.
Can anybody try typing that if it will come on your side? I'm putting on the chat box.
We use ggplot2 or ggplot.
Just call both you have downloaded. Just call both libraries.
What did we? So what are we supposed to do?
Yeah, I'm putting in the chat box. We are setting the to run the model. Now, if you used lowercase letters in assigning, just use COVID, but with lowercase letters.
Plot2. Forecast.
Yeah, Professor, you have not sent me a file on my email. What I'm getting is just the subject COVID. The file I loaded were wrong because they had 3 columns. Afro, Ameri, and CA. It's a bit different file. So it's
I
not
used
the
the one on the mail, on the group WhatsApp.
No, I'm not on the group WhatsApp. The admin should add my name. I'm not there. But the COVID file I had was the previous one. So my R is showing 4 columns.
No, this one.
And in the email, it's just the subject COVID.
Livingston, did you find it?
It was not attached. I've used what Peter was seeking, but I can attach back to her.
Okay, please.
I can send it to her.
Prof.
Yes.
I've been struggling to do this thing, but now after I've gotten now the COVID, the file now. So what next?
Have you called it?
Take us through what calling is.
Calling means you import it into your R console and then you load it and it shows the data points as they appear. That is what we mean by calling it.
Just take us through the process, please.
Yeah, because
remind us.
Okay, like you see, I said mine was capital COVID, okay? I call it using capital. Or I can actually use the first one. Let me see, just say any name. But since there's another data here in my data set called COVID, so I can write COVID-3. And that, and read.csv. Close the bracket, open the bracket, file, dot choose, double bracket, enter. Then it takes me to where I had put it. And then I open. Nothing happens, doesn't show me an error. So calling it means I now tap COVID-3. So I want to use it and enter. After typing, you enter. That is how we do it.
So from there, I got lost.
Who else is able to reach there?
I reached there, but when I entered library, now I got errors.
Yeah, your library is not there. It means you did not install the library. Then after doing this, you type library. Yes?
No, Prof, before that, so up there, calling it, because I got the COVID, it actually didn't show an error. So how do I call it now?
It
Need to
didn't
get
give you
this
error.
name.
Okay.
No, it didn't give me error. It just, yeah.
Look at my cursor. After I had imported it, I saw COVID-3 assignment operator read.csv into bracket file.choose close double bracket. Then I entered. After entering, I typed COVID-3 and entered. Enter. After type COVID-3, how you call it, then enter. Every time you type that, then you enter. That's what we mean call it.
Now, if I write COVID-3, enter, it's an error now.
No, How did you save it on the R console?
COVID.
How did you assign it when you are calling, when you are importing it? Did you say COVID equals to COVID assignment operator? Was it capital or small letters?
It was
How
small
you
letters.
assign it is how you, yes. So use the same letters you assigned it.
Okay.
Yes, that's how it will come.
Good.
Maybe you show us the library. My library is not there, showing error. Whether I try ggplot, it's still error.
It means it didn't download. You didn't actually download it.
So, Prof, after these numbers, what do we do now?
After all these numbers,
yes.
Now that's the time you said to use this code. You use model because we use a RIMA model. So just say model. You can say
But the library, after calling the COVID, Prof, then what else after that?
Has it come?
Yeah, it has come. The Afro, the America. Yeah. So what's next?
No. We are not talking about that one. That one was only for ANOVA. The one we are talking about now, if you see my screen, is the one that Wasiki has shared on the chat box. You're using a wrong one.
Prof, please scroll down to the code you had down there.
Which code?
That was the one that was ADF.
No. That was trying something else.
Okay.
Yes. I'm just playing with other things.
So, Prof, I have to start afresh.
Yes. The only thing you don't do is you have to, if you had you had downloaded the packages, all you do is just to import this data and start using it.
Excuse me, Prof.
Yes.
No, the data I'm getting, I'm not saying like it's the one you have, where we have sigma, AIC, likelihood. What is that? The coefficients or something like that.
Oh, you have already gone there.
Where?
You are talking about this one, isn't it?
Oh.
The likelihood,
I'm talking
things
about
like
the
that.
one up there. Yeah, not this last one. When you are doing COVID-3, you are calling the one.
I've heard you saying about likelihood, things like that.
Yes.
That was we just starting the initial stages of running the model. I want everybody to, at least significant number of people to be able to have this data. Then we run it together.
Okay.
So, Prof, this one, when I call it, it's an error. The one that had been shared on the chat, what could have been the problem? Not found.
I downloaded it.
I have.
You are not able to import it into the console.
To call it, I already imported it, but I can't recall it.
How you have assigned it is the way you call it. Like you see in mine, I said COVID-3, assignment operator. So after I have written that code, I enter, then again write COVID-3 and then enter. So can you write that and enter? Make sure you're using the same way you wrote it. You assigned it. It's COVID fees for small letters, lowercase letters. That is what you're using. It is uppercase, that's how you're using it. Otherwise, you'll continue getting errors.
You can even call your name.
You can even give it your name, and if that is okay.
I've reinstalled the library twice. It's successful, but when I move, still tells me package or namespace load failed for ggplot2.
Yeah, come again.
I've reinstalled twice and it shows the packages are successfully installed.
ggplot2.
Yes, actually it says package ggplot2 successfully unpacked and MDS sum checked.
Okay.
Same to package forecast. But when I do library ggplot2, it gives error. Package on namespace load failed for ggplot2.
Now, did you write everything correct? The brackets, the name, and everything.
I'm using what you have typed here.
So by show of hands, how many people are able to reach here where this data is? We have many data points. They are 967 data set by show of hands.
Prof, I'm still having a challenge, even after putting this COVID-3. I saved it as COVID-3 in caps, but if I put it, still it's just showing an error. It's just saying not found.
No, what is not found?
When I'm recalling.
Did you, are you able to share your screen?
Yes. Let me see.
Let me stop sharing, then share your screen, because we want to start doing the analysis. Thank you for those who have reached there.
Mine is also still saying the same error, not found.
Yeah, I want to see the other one, the other guy. They want to see the screen of this.
Prof, kindly
It's telling me
lab
host
code.
disabled participant screen share.
Oh, so you are disabled. You
Yes.
can't share unless you are made the host.
I can take a screenshot and share in the chat.
Okay, okay. So for those who have successfully called this code, this data here, I want you to do this. Write model. It's ARIMA, so you can say ARIMA, then assignment operator, then auto dot ARIMA, small letters, auto dot ARIMA. COVID, how you saved it? Mine was, there was the bigger one. with 3. After you've done that, I'm putting it on chat box. Here. Paste. And right. Then you call it. This is what I mean by calling it. Then you have that output. After that, you just say arima and enter. Just that. So this gives us, you can see it says series COVID-3. For example, in your case, it will say series COVID, how you call it. Then it says arima 0,1,3 with drift. What that one means, our P, which was the number of lags, is 0. It doesn't do 0 lags. Our integrated is 1. Only 1 integrated. Then moving averages are 3. That is what it's telling us. Then it tells us the likelihood. What we are doing here is we are selecting what is called information criteria. Which one is good for us? For instance, if you just summarize, If you just summarize this, it says summary. It's not showing it. Summary, arima, and enter. You will see that this code has tried to give us several other options which give different variances down here, and it chooses the one with the least variance. But the fact that there is a drift, remember we said that it must be stationary. So this drift means if we use this data as it is, the results, yes, we will get results, but the results will not be accurate. Drift, it has a drift.
What is a drift in mother tongue? Because now we don't even know what drift is.
Prof, before you answer that,
yes,
because it's probably connected. Now that we are with you, we have
yes,
the output.
yes.
What's the story here without the now in relation to COVID-19?
Yes.
The drift, the moving averages in relation to the COVID cases. Maybe that will help understand it better.
We are looking at this data. This is not even actually the model we are going to run. These are still more of preliminary processes. We are asking our auto arima to select for us the best model to run where the correct number of lags, P, the correct number of integration, 1, correct number of moving averages. Yes. So it has only given us that we used the integration 1 and moving averages 3. 3 moving averages, but it has a drift. But we can remove the drift. Let me see if we can remove the drift. But I wanted us to run the whole thing down, then we deal with diagnostics later.
Prof, before you remove the drift, I'm not able to find Otoi. Was I to download it?
No, it is in ggplot.
Sorry?
It is in ggplot 2.
It's telling me error in Otoi COVID could not find function Otoi.
It is auto.arima, okay?
Yeah.
And what was your action before then? Before Otoi? Please
I just said a model.
scroll upwards so that you can see your. Please scroll outside upwards your screen. We see from the data what were your actions.
My action was here.
Okay, fine.
Yeah. You can call this anything, even your name. Then instead of Arima, you can just say everything, even your name. So here we are still at preliminary stages of doing certain diagnostics. Yes. I don't have
Excuse me, Prof.
Yes.
I was with you until model. Now, when I did summary Arima into brackets, I was told it's found.
Summary.
Yes.
No, how did you, you just said summary model. You've realized I've run 2 models here. Just write summary model. You see what happens.
All right, thank you.
Summary. So, we've seen this one as a drift.
Mwalimu, sorry to take you back, but I'm stuck. I shared where I'm at on the chat box. I've tried to reinstall those ggplot and forecast. They still give an error.
It has not been successful.
Okay, what should I need to do to make it successful?
I'm trying to see what you shared here on the chat.
Even I'm still stuck there, can't move.
Let's see, I'm trying to see what happened here.
Mwalimu, what does the training set errors mean in this up to?
Tracy, when you are calling this data, you used COVID, assignment operator, read.csv into bracket file.choose and close. That was done very correctly. However, when you are calling, you called COVID-3, which is not the case. You should just call COVID the way you had imported it. Just call COVID. It will come. Try. In small lowercase letters. That is the error on your side.
Prof, can you go up where you inputted ARIMA?
Just a minute.
Where you started the input for ARIMA before you got the coefficients just up? Because I'm with you up to div COVID, div test COVID.
You are with me up to?
Up to where I have 967. Then I moved to div test, div. Then now the ARIMA part, that one is not bringing anything.
Are you able to see my screen?
Yeah, you can move up.
Okay. There?
Yeah, so now this ARIMA auto assignment operator is ARIMA is where you said I can use a name, or that's a standard formula?
Yeah, this is where you can use anything, that ARIMA part, because you're just assigning it at any name.
Okay. So if I call it myself, let me use just ARIMA the way you have done it, because I don't have it here in capital. Then it doesn't give me.
Mine shows different number. The coefficient
Yes,
is not this. The coefficient is not the same like yours, and also the stigma and likelihood. Yeah.
They're not the same as mine.
Yeah, they're not the same like yours.
But they have come nonetheless.
Yes.
Good.
I've posted my screenshots on the chat because I don't understand why it's saying could not find function auto.arima. Was I to do something before these calculations?
No, it's like, was it successfully downloaded on your side?
I was to download AutoArima.
You have to download ggplot2.
Yes.
And Forecast.
Okay, Forecast is what I haven't.
Download it. Now, for those who have reached here, I want us to check something. Can you type plot? I want us to plot and see what's happening. Plot.ts. The model you used, how you called it. In my case, the first I called ARIMA. Now next I call just model. Are you able to, are you seeing what I have done? Try to plot your model. I'm putting it on the chat box for those who have reached here. I'm putting it on the chat box for those who are able to reach here. Yeah, I'm asking you to plot a time series of the residuals of the model you have used and see if you get that.
Mwalimu, I have it.
Just like that, okay?
Mwalimu, I'm there, but I was wondering if you could explain about before we've plotted the training. What's this training set? What does it imply, or what does it mean?
This training set error measures. Those are residuals, variances of if we were to run this using a different order of PDQ. You see the order here is 0, 1, and 3. Now, this model selects for us the best information criteria. You see just above the summary there is AIC. AIC, then there is AIC small c, then there's BIC. AIC only means archaic information criteria of choosing the best model. It's a criteria for choosing which the software uses to choose which model. And BIC, so they'll choose the one with the least variances. If you look at above the summary ARIMA, there's 23,734, the other 0.75. Then the other one, 23,734.82, which is bigger than this one by some 0.07. Then this other one is 23,759.12, which is much higher than the rest. So the one with the least variance is the AIC. But when they run the AIC, it gives us the order of 0, P. The number of lags here is 0. We don't need a lag. Integration is 1. And the moving average is 1. The integration where you can't see this one means it is self-integrating. But the moving averages are suggested for us to use 3 moving averages, and it has given their values. That we were selecting the correct specification of the model, which kind of ARIMA model to use. How should we order the lag, the integration, and the moving averages? That is what that preliminary thing has done to us. We have not reached the ARIMA part of it. We are still selecting. So I was asking you to run the model to visualize the residuals. You see, up to 967 days of COVID infection in Kenya, we had waves. You see, this is wave 1, wave 2, and wave 3, which can be seen from the residuals, which we have tried to analyze. But this is still preliminary. So I want everybody to try to plot that.
Doctor, I have shared mine on chat. It's the same numbers, but different diagram.
Okay, we had a drift. Yours, it's drifting differently.
Yes.
Yes, it's drifting differently. That's why. So
Why should it drift differently if she's using the same data? If she's using the same data set as us, why is she getting different drift?
Which version did she download of R?
Oh, okay.
And the packages, they are being consistently being worked on. Now, if we will be in a position to remove all the drift, it will not have different diagrams. So now let's
question, Prof.
Yes.
On the chart, I'm not understanding the chart because the numbers that we are talking about are 2,000, and as we are on one side is 5,000, the other side is 200. I'm not relating.
Which side?
The time. For example, the time, the one, is it the x-axis or the y-axis? The x. Like now the x-axis, where is it in that data that we had of the summary? And also the y-axis, I don't know whether it's the residual, there is that one.
The x-axis are the number of days of infection. Well, we have 967 days, which are here.
In time.
This is 1,000, but you see, this is slightly.
Below.
Yeah.
Okay.
Yeah. Okay. So there are some diagnostics we can use, but I want us to run a model so that we can reach what we are talking about as the model. It's a very interesting kind of thing when we run this model. Let's say, let me type it on the chat box. The first thing we were doing that kind of modeling was to select the number of lags, the number of integration, the number of moving averages. Yeah, now let us run a RIMA model, the one that works for everybody. That all people are using to do that.
I can see, Prof, that you have used now model 2.
Yeah, we want to separate it from the model we have used first, because you see, this thing is case sensitive. You just bring the other one if you don't change it. Give it, assign a different name. So just bring the other one.
So basically, for those of us who called it ARIMA, we can call it ARIMA 2.
Yes.
Awesome.
ARIMA or model?
If you use model, call it model 2 now.
Yeah.
Yes.
Please scroll back down to the formula so we can catch up.
I'm going to put that in the chat box so that you can follow.
Good morning.
Okay. So if I may explain, you saw that in the first instance,
Yes, this is Millie.
when we ran
Yes.
To Arima and Case and
No, we are still continuing. Still continuing. Yes.
Caroline, please mute.
It selected for us what it perceived to be the best model to run. And it always chooses one with the least variation, with the least variance. So if you look at this, it has given us a list of possible models we can use from Arima 1, 2, 3, where we have 2 lags, integrated ones, and 2 moving averages. But it has a variance of 24,000 and 29.73. All of them have that high variation, 24, 24, until we reach 23, 23, 23. Then the one it had selected for us early is this one, 013, which has the least variation. This means that the one that explains the variations, the most variations are explained. So this one that has the least variation is the Arima that this R has chosen for us. That is why it has selected this. And if you see this is what we also got up here. This is what we got up here. So when you run that, it gives you all possible specification in terms of lags, integration, and moving averages. But then goes ahead to choose for you the best fit that you want. So that is what has happened here. So I want you to reach there, then we proceed.
I just have a question.
Yes.
So when you are doing model 2 Autorima COVID-3, if I was using the data that had COVID in capital, do I just put the COVID in caps?
Yeah, sure.
So when I do that, what do I call?
The COVID in you call, if you're doing the RMA, just call the RMA, the one that you were doing. You see here. I see after auto Arima, Arima is, or if it's model Arima, assignment operator, auto.arima is a function into bracket, COVID-3 close the bracket. Now I come and call Arima. Then it gives this. If I used model like I used in the first case, it's a lot of data. Collecting data for 3 years is not easy. Here I used the model. Auto Arima, COVID in capital. I called model here, it comes. So with this, we are given, we want to do forecasting. I want us, all of us to reach here, then we do forecasting. but we can run some tests here. We can run some tests here. ACF dot into bracket time series model a residual. We used which model? Model 2. Model 2. $sign residual, close the bracket, comma, main equals to ACF residuals, close the bracket, and enter.
Please send the command on chat.
Yeah, this is just trying to check if the data we have used is autocorrelated. This test. It shows if the data we have used, if there is some kind of autocorrelation in this. Like ACF is autocorrelation function, ACF. Then we can also check partial autocorrelation in case there is partial autocorrelation. You see, now it makes it broader. Now you can see the small sticks up and down. Shows our data is autocorrelated. They're up, down, but it's not autocorrelated. PSCF zooms into the figure and sees. Let me also put it on the chat box. So the most interesting part is what we are going into. We are going into forecasting. So those who are in whichever area can, in their organizations, in their companies, wherever you work, you can predict things. Tell them this is what we expect to happen. And say that with authority. Isn't that a lot of power, Victoria?
Not yet.
I'm saying it's a lot of power to predict things.
Yes.
Thank you, Gabin. Can you imagine in a situation where in the whole organization, the only person who can fold his arms like this with authority and say that this is what is going to happen, and then it happens. It's empowering.
And Professor, when are you in the office so that perhaps we pay you a visit to get a lot of clarity on this, because this is very important. Everybody's looking at the prophets of statistics, and it's very interesting, although a little bit complicated because of the science.
The whole of next speaker will not be available. The graduate school where I'm assigned is serving some activities out of town. But a week after that, I'll be fully available from Monday to Friday.
I have a question, Prof.
Yes, please.
In your last command, in your last command where you have used the partial ACF, why haven't you used it on this other side? You have still retained the ACF.
But see, they're different. Yes, that is right. That is very, very right. I should have put here PACF. PACF. But it would make no difference because I had assigned on the other side. So now we want to do forecast. We want to do forecast. We can say, let's say COVID forecast. Leave the study. COVID forecast. Assignment operator. Forecast is a function, sorry. Forecast.
Prof, a random question.
Yes.
What happens when the assignment operator becomes a plus? What does that mean?
Have you tried? Has it worked for you?
When I was running the first, is it Otoi? No, the first ACF, the formula shared.
Yes.
When I pressed enter, it gave me a plus, but it did not run anything.
It did not run?
It did not give any output, just a plus.
Yeah, it doesn't recognize. And if you enter, nothing happened.
Yes.
Yeah, it doesn't recognize that.
Maybe you didn't assign maybe the brackets or something. It happened to me, and I realized that I missed on some commands.
Okay.
So just check your operator.
Okay.
Make sure this is scan sensitive and the specificity. So we want to focus COVID cases using our model 2 at 95 confidence interval. At 95 confidence interval, and we want to see what it will look like 100 days to come, at least at that time, up to that time. Now, let me put the codes in the chat box so that you can try it on your own and see the forecast. When you reach there, then we start interpreting.
What does H stand for in the operation?
The number of times you want to. H is equals to 1. High. After, if H equals to 1, how many times, what is the period in which you need to take it? That is H 1 times 100, ahead, head, heading to 100 days to come. What will happen? So H is the number of times you want it to be forecasting. How long? Now, yeah, we want to do it in 100 years. For those who are in finance, you can try to.
How would you know?
Yes?
Sorry, Prof. So it is heading to from the first day,
to
or is
100
it from? Is it first day or first year?
For COVID, it was for the day, I mean, next day, from next day to 100 days to come.
Okay, so 100 days, not 100 years, because I was going to
100 days to come. Because
Okay.
data is collected in days. If your
Okay.
data is collected in years in organized, for example, if it is GDP, you can see what will it be in 100 years.
Yeah. Yep.
Yeah. How many of us are here? Go ahead. You see, when you are learning mathematics, time goes without noticing. Archimedes, the famous guy of Eureka, when the Romans attacked Spain, and Archimedes was busy calculating something in the sand. Then a soldier came and asked him a question. He told the soldier that he's busy, he'll answer that question later. Then the guy told him, if you don't, I'm going to kill you. Then he was killed while still doing his calculation. It's a very intriguing thing. If you reach there by show of hands, I'd want to know. Kawira, wonderful. Jan Fazara, great, great, great. John, wonderful. Caroline, good. Good, good. So, what happens here? We have the forecast, we have a lower limit, and then we have higher limit. There's the forecast, lower limit, and higher limit. That is why we have forecast. If you look at that data, from day 968, remember our data is ending on day 967. So this forecast starts from 968 plus 100, that should be 1,068 days and 67 days, 1,067 days, because we wanted this for those number of 100 days. So here we are given this data, these predictions, forecast for all those number of days. The lowest, the least, and the highest within that confidence interval. Now, it is not very easy to, we want to visualize this. Things are easier said in pictures than when you say them in words. So let's see. We can plot this. And see how it looks like. What the plot looks like. They say a picture is worth 1,000 words. So you are seeing the shaded region, and then there is the blue line there inside. The blue line is the forecast. The flaps of the shaded line are the lower and the upper limit. We expect the least to be this, the maximum to be this. But look at the possible accuracy of the blue line. If you are able to do that forecast, raise your hand. Good, 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 good.
Just a question, Prof.
Go ahead.
The high and low, that one is understandable. Now, this other one, is it the average or the median or something like that?
Yeah, the forecast is actually in the middle.
Okay.
It is actually the difference between the highest and the lowest. So the publication I shared in the chat in the WhatsApp group yesterday is one of the papers that initial papers that we published when predicting the spread. However, the one I invented has more bigger, more accurate calculations. It first started with deriving a lot of derivation. Should actually be at the back of the book that I recommended. I will share both of them in the WhatsApp group. Read both of them and see how good they are. So some of us here who are in education, or your projects could be in education, could be in finance, could be this. I would want you to be in a position to publish a paper on the predictions of stock exchange. I remember when I started modeling, some people told me that instead of predicting COVID, why don't I predict stock exchange? It will give people and myself more money. I was reluctant because people were dying in my country and I must be of service to humanity. So those people are in finance. This is a very powerful tool that empowers you to inform your organization what is going to happen, your projections, to be more scientific and accurate. Now, if we had removed the drift in this data, we would have had a more very accurate forecast. So up to now, I can comfortably say we have run an ARIMA model and we have forecasted. Now the work is on you. How you are going to use this information you get in this class to impact your work environment is not my business. My business is to make you do this, which you have done. Okay? Questions?
Yeah.
We have gone beyond time. You know, we are always supposed to end by 8 because we start at 6, but now we have gone, we are approaching 10.
Yeah,
So yes.
Prof, with my interest is in human development. I want to focus on how a child can be brought up to become a professor like you. So how do I apply this?
That depends on the variables that you're going to use. How you're going to use those variables. You can imagine the kind of variables you're going to use. If a child is going to become a professor like myself, many things are at play here. Which variables do you think are usable? I am in academia. So can you use academic reports of this child to try to forecast what they will be? Or can you use some other nuances, like how long in one day does this child read or study? In one day, how long do they play? How long do they, what are their hobbies? What are the habits? There is the element of nurture and nature coming into play. is the nature of reading and the nurture by the parenthood. So a lot of consideration will go into what variables to employ in running such a model, which we can discuss further if we get time between the two of us.
I'll look for you. But
okay,
the bottom line is that it's possible.
Yeah, it's possible. It's possible.
Oh, I'll look for you.
Nothing is impossible to him who will try, or to she who will try. Charity. Your
Yes,
hand is
Malim.
up.
Oh,
Yes.
no, that was an old hand. Sorry.
Okay. Anybody with a question? Victoria?
Yeah, I posted mine on the chat. Can this be used to forecast the weather? Perhaps by measuring the rain volumes, the wind strength, the intensity of the sun, the presence of water bodies for humidity, or something like that.
Yes. So now we have aspects of modeling and forecast. One of them is climate modeling. There are globally 3 climate modeling, international climate modeling centers. One is the Canadian Climate Modeling Center in Canada. Then there is the Simon Laplace Institute, Climate Modeling in Paris. There's another one in the UK. This can be used to forecast weather. It can be refined a lot better. When we forecast climate, we are looking at one, the temperatures. We are looking at humidity. We're looking at wind speed. There are many other aspects that we use to forecast weather. The object here is to ensure that we are able to predict extreme weather, when they occur, how long they will occur, and the extent of damage that they will have. Why do we do this? We are doing this to inform mitigation so that we are not caught flat-footed as a country, as a region, as a globe, that things happen. For instance, the last that happened 2 weeks ago, when the floods killed over 163 people in Texas, United States of America. The river burst its banks and those people died. You can imagine how the weatherman there felt. Felt quite not very useful to their country. And many are lost. In 2024, around 16,758 people lost their lives because of extreme weather, floods, heat wave, even drought. So if we would be in a position to do this on climate, beyond weather, climate, we can be of great help to ourselves, to humanity, and to the planet. It is a subject very dear to me, especially as a disease modeling expert. I know that we are moving into the area of what we call One Health, where One Health means healthy environment, healthy animals, and healthy humans. Now, if we interfere with the environment, this relocation loss of biodiversity will bring about food insecurity, and we will start eating foods that will infect us, like the Chinese in the Wuhan wet market decided to eat birds, and then the virus called COVID-19 jumped from the birds to humans, and we lost 7 million people on this planet. Most of us in our families lost people, and it's affected 701 million people on the climate. You can imagine how just one gap in ecosystem equilibrium can cause such a huge damage. If you look at it from policy and scientific understanding of things, you can see how adverse that is and how significant your question is in this generation. While most of us are busy looking for money here and there and left and center, we forget about the environment. But is it sustainable in the long run? No. In Africa, our global emission of greenhouse gases is 1.9%. That 1.9% in Africa, 1.3 comes from South Africa. So between the Sahara Desert and the Zambezi River, we only produce 0.3% of global emission of greenhouse gases, yet we have terrible disasters here. Now, countries that are contributing a lot of greenhouse gases that cause global warming and result in extreme weather and extreme climatic conditions have what is called carbon taxation. The amount of money you pay to emit 1 ton of greenhouse gases into the environment. But how does that mitigate the environment? In Africa, it is only South Africa that is paying carbon taxes because it is the only country emitting almost 70% or 80% of greenhouse gases emitted in Africa. So what should the debate shift to? Should it shift to carbon taxation or just elimination of unclean energy, use of unclean energy in totality? Those are the kind of debates that we should have globally. So yes, Charity, then Victoria, that is the answer. Sorry for that elaborate answer. And I am actually very concerned about climate modeling.
Yeah, Professor, I wanted also to add something because climate is my area of specialization. And I remember in a tsunami in Japan, actually a person who predicted that tsunami like 2 years was actually given some prize. She was called Tasuki, and she was because she was able to bring up the data for modeling that they're gonna be a big disaster, but many people didn't take her seriously. Secondly, Kenya, where it is now being applied, when the government declares disaster like drought, it actually attract funding from the treasury. Treasury can only release cash to be spent on a disaster when it's declared, when the president declares maybe drought as a national disaster or flooding. But before then, there's a lot of modeling that goes on behind, so that actually when they are declaring that drought, you could declare that we're gonna have drought. Then sooner or later the rain just comes. Then actually you lose credibility. So this modeling is very much applicable, so that when you do the right modeling, it can actually save lives and save income as well. Thank you.
Yes, thank you for that explanation. Now, when somebody graduates from a university, whether it is master's, bachelor's, and most importantly, PhD, you are given the powers to do and read all that appertains. You are not limited into, you are not told, no, don't go in this area. No. You are supposed to provide solutions to humanity in whichever area you choose. Now, with being in this class and given the capacity to forecast, to model and forecast, if you take this class seriously, you are different from all the other people in the organization in that you can certainly tell what is going to happen, how much sales, how much what we're going to have based on the data in that organization. And that is a lot of power. And this is where we are going. This does not come when we teach statistics the traditional way, where we do all the calculations and find nowhere to apply them. Now, if we teach that with the software and tell people how to do it, you're facilitated to use this. That is how I see it. Anybody else with a question?
Mwalimu, when I was plotting the COVID forecast, it was bringing an error at the last stage.
Where was the error coming from?
Just when I type plot COVID forecast, it brings an error.
It depends on how you saved. Check one, if they are all in lowercase letters in case you use lowercase, or if you missed even one letter, it will always bring an error.
Prof. Prof,
Yes,
yesterday, Trump just sacked his chief statistics officer for labor for producing numbers that showed some slump in employment. He was fired. Are you telling us with these powers, we should have the courage to publish and perish? Or what do you do when you know your employer is likely to sack you?
Truth defends itself. Truth defends itself. Why don't you take it from me? And if you have read that book, the moment I started modeling and I told people we are going to have a wave, including Camry were resisting many things. And I said, wait and see. And it happened. People don't argue with facts. Now, the reason why we have two classes of scientists. We have those that are fastidious to scientific rigor and truth. And we have those who want to please the government because they want appointments in government, they want some favors. The difference is that they perish at the long run. In the long run. You stand up with your truth, make sure your processes are rigorous. Being sacked in one organization might be a God's message that you no longer needed there. There's somewhere better for you, and you should go there. That's how I see it, how sad as it is. But mathematics is about finding the truth. It is only in mathematics that we solve problems. You're given a problem to solve. So we should be we should exercise fidelity to truth.
Thank you.
Thank you. So if you want to consult me, you can consult me after next week. As I said, when we started this class, that this is beyond passing examination. It goes beyond classroom to your workplace to solutions around in your environment and around the world. And I hope we are living to those standards. If there are no other questions.
Prof, may I ask the last question?
Is there? Yes, please.
The last question is on the assignment. We have been struggling. How are we supposed to present that assignment? Then we take photos, and then what are we supposed to do it? How are we supposed to do it?
No. You run your ANAVA model, and I want the interpretation clearly written in a Word document. Clearly written with Word document. And I want at the end of it an ANOVA table that is showing everything from treatment, sum of degrees of freedom, sum of squares, mean sum of squares, the F value, and the significance. I also want that diagram showing confidence interval among the infection in different regions. But they are all submitted in a Word document. Do not copy paste all the codes and put for me. No. I want it in a Word document, explanation, and a table.
Is the data we are using for ANOVA, Professor, is that the same data that you used for your COVID analysis?
Of course.
Now that, of course, also raises the next question. The conclusion for my case, the conclusion I was arriving at is not the same as the conclusion that's in the book. And maybe I can consult outside of class.
No. Provided you can explain and defend your conclusion. Yeah. That's okay.
Okay.
That's okay. Provided you can defend. And have you wondered why a PhD there's always a defense?
Defend your lie.
Yeah. That is why you are in this level of education. You hold a position and defend it.
Prof, what is the maximum pages you expect from this assignment?
At most 2 pages, at most. at most 2 pages. So
Would you please extend for us the deadline, or for me?
it would have been extended by 1 week.
Oh.
Yes, yes. So from today, I want to be very proud of you people. If you are able to, in your various organizations where you work, you're able to sit down with the board and tell them, I have predicted, I have forecast this, and we are looking at this in the near future, in 30 days, in 100 days, in 1 year, in 3 years, and defend it. That is when you are learning. And that is when you are benefiting from this class, not only for the purposes of exam. In fact, I don't care about exams. They don't bring out a clear picture about your abilities. I always tell people, the product of your PhD is not your thesis. It is you. What are you able to do? So with those many long lectures, we can end the class and wish everybody well until next week. Who will close for us? With a comment and prayer, then we leave. All of a sudden, we have become religious. Carolyn, pray for us.
Okay, thank you, Prof. I will pray for us, and thank you so much for the classes. We definitely are not coming out of this empty-headed. There is lots of benefit, but there is a lot for us to learn, even as we, catch up with what we have. Let's bow down and pray. Almighty Father, we thank you. We bless your name. Thank you, Lord, for this day. Thank you for the days that you've given us in this class. We still have more ahead of us. We pray for wisdom, Jehovah, that as we proceed, as we continue learning, as we explore in our workplaces, in day-to-day life, may these be applicable and relevant in our lives. May we also impact the world as we go out to apply all that we are learning here. We thank you. We bless your name because this is our humble prayer in Jesus' name. Amen. Happy Sabbath. Bye-bye, everyone. See ya next week.
Yeah. Make sure that if I send you articles, you read them.
Yeah.
Okay, Prof.
Okay. Thank you. Thank you. Enjoy the rest of your day.
Thank you. You as well.
Sorry.